Introduction to the brand new finding. In a bold statement, researchers have claimed to have discovered a planet unlike anything else we've seen before. NASA, famous for its revolutionary discoveries, has disclosed that this planet is captivating not only due to its size and location, but also because of its emission of light that appears to be artificial. NASA might be on the verge of uncovering hidden truths that could drastically alter our comprehension of the universe. This might serve as a starting point toward the possibility of life on other worlds. By delving into NASA's groundbreaking discoveries, we may soon discover the truth about this astonishing phenomenon. In 2007, NASA launched the Dawn spacecraft with the goal of exploring some of the most fascinating bodies in our solar system. Equipped with 3 ion engines, Dawn set out on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back highly detailed images and data, shedding light on Vesta's intricate surface and varied geological history. After completing its mission at Vesta, Dawn proceeded to the second phase of its journey, one that was likely even more thrilling, a comprehensive examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to escape Vesta's sphere of influence and head toward Ceres, a feat that would have been unattainable using conventional chemical propulsion systems. These engines provided steady thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, located between Mars and Jupiter. For 4 years, it was considered to be the tiniest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt. One of the most captivating features of Ceres is its unique attributes. Scientists eagerly awaited the first close-up images of this mysterious planet, which revealed brilliant spots scattered across its surface, particularly in a large crater. These bright spots, notably an Ocata crater, sparked immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Very little was known about the promise and nature of this tiny planet. Detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our comprehension of the solar system's formation and investigate the role of water in the evolution of planetary bodies. Bright spots on Ceres, also observed on other asteroids, might be made of highly reflective materials, possibly salts left behind by water that has evaporated. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts brine or water rather than molten rock. But what exactly are these enigmatic lights, and what do they reveal about the actual nature of Ceres? Could they be signs of ongoing geological processes, or something even more exceptional? Ceres stands out among other asteroid belt objects due to its size, mass, composition, and the possible presence of ice and water. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began the process of orbiting Ceres in early 2015, marking a significant milestone. As it neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial images exhibited a surface cratered by a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the resolution of the images improved, scientists began to formulate theories about the nature of these spots. Were they ice reflecting sunlight, or could they be something even more remarkable? Speculation ranged from mineral deposits to potential indications of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature but rather an assortment of distinct areas. The most widely accepted explanation was that these were salt debris left after water sublimated. This suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it quickly dissipates, leaving behind bright reflective residues. These findings challenged previous ideas about Ceres, creating an image of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our awareness of the potential for life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water, ice and hydrated minerals, including clays and carbonates, giving it a structure with less density than its rocky neighboring asteroids. This composition suggests that Ceres may harbor significant amounts of water, both beneath and on its surface. Its outer layer is rocky but porous, with trapped ice and other volatiles, making it more like a comet than a typical asteroid. It is believed that Ceres has a unique internal structure, consisting of a core containing a lot of water ice, which makes up about half of the planet's total volume. Its mantle is likely a mixture of rock and brine surrounding a denser core, possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres might have previously supported liquid water, especially if its core was heated by radioactive decay during its early history. This internal composition sets Ceres apart from its neighboring asteroids and opens up fascinating questions regarding its potential for geological activity and the role that water plays in its development. It suggests that environments we previously thought to be static or barren might actually be dynamic, and even capable of supporting the conditions necessary for life. If cryovolcanism can maintain pockets of liquid water beneath an icy surface, even temporarily, it dramatically expands the range of worlds we must consider when searching for extraterrestrial life. This discovery reshapes our exploration strategies. Instead of focusing only on Earth-like planets in the habitable zone around stars, scientists are now considering icy bodies with internal heat sources as potential habitats. Worlds that seem too cold or too small to sustain life might, under certain conditions, harbor microbial ecosystems hidden beneath their surfaces. Furthermore, the artificial appearance of the bright lights on Ceres, as some researchers have boldly speculated, stirs deeper questions. Could these luminous spots hint at something beyond natural geological phenomena? While the most widely accepted explanation remains reflective salt deposits from cryovolcanic activity, a sliver of the scientific community remains open to more exotic possibilities, including the potential of alien technology or unknown natural processes yet to be understood. NASA's Dawn mission, originally intended just to study two of the solar system's oldest bodies, has instead ignited one of the most profound debates in modern planetary science. It has challenged assumptions about where life might exist, revealed that geological activity can persist in unexpected places, and shown that even in the cold, dark reaches of the asteroid belt, dynamic worlds can thrive. As we look forward, missions like the European Space Agency's Hera mission and future NASA endeavors will continue to investigate small worlds like Ceres. There are even proposals to return to Ceres with a lander, or even a sample return mission, to study the bright spots directly and determine whether they are merely salt flats from ancient underground oceans or something much more astonishing. In the grand tapestry of space exploration, Ceres serves as a vivid reminder that the universe is far stranger, more active, and more promising than we ever dared to dream. The glowing mysteries of Ceres might not only reshape our understanding of our own solar system, they might hint at an entirely new chapter in the search for life beyond Earth. Hostile might actually be dynamic and able to provide support for complex processes. It could also indicate that other far-off worlds, once thought to be ice-cold and lifeless, could be home to conditions conducive to life. NASA's Dawn mission continues to stand as a testimony to the strength of space exploration. The data it has returned has already reshaped our understanding of the solar system's formation and evolution. As we investigate more about Ceres and other far-off mysterious bodies, with each new discovery, a piece of the puzzle of how planets, moons, and other celestial bodies change over time is revealed. For now, the bright spots on Ceres continue to be one of the most fascinating phenomena found in our investigation of the cosmos. But they are only the beginning. As technology advances and more missions are launched, the possibility of even greater revelations looms large. Ceres, which once seemed like an obscure and forgotten dwarf planet in the vast asteroid belt, today serves as a beacon of mystery and potential. Its surface, internal structure, and enigmatic bright spots may one day provide the key to understanding the early solar system and the processes that led to the formation of planets and other bodies. The potential for life, or the elements necessary for it, is an exciting possibility that continues to motivate scientists and space enthusiasts alike. As we continue to explore Ceres and other distant worlds, the line between science fiction and reality continues to blur. The idea of life on other planets, once a subject of speculation and imagination, is now a real and important question. Might underground life, made of microorganisms, exist? Could Ceres water pockets harbor life? Could the conditions on other icy moons in our solar system be suitable for life as we know it, or even life that we've yet to imagine? Consider these to be the inquiries that will drive the next space exploration boom. They may ultimately lead to unlocking the universe's mysteries in the years ahead. As we strive to send more spacecraft, and possibly humans, to explore these distant worlds, future missions, and Dawn's findings will shape our understanding of what is possible in the universe. From Ceres' icy surface to its bright spots that may point to the presence of liquid water, the dwarf planet serves as an example that there is still so much we don't know about our solar system and the many wonders it holds. Ceres' story is far from over. With each new discovery, we come closer to uncovering the secrets of this fascinating world. As the Dawn mission continues to send back groundbreaking data, numerous scientific ideas are being rethought. Scientists are re-evaluating their preconceived notions. The presence of bright spots and evidence of cryovolcanism points to the possibility that Ceres may have undergone geological activity for much longer than previously believed. Most stars and planetary bodies of this size are assumed to be dormant after billions of years. However, the active processes occurring on Ceres suggest that its interior might still contain areas of liquid or brittle water capable of fueling activity beneath the surface. This is a fascinating prospect, as it challenges the idea that small moons or planets are unable to sustain long-term geological processes. The discovery of Ceres' potential water storage facilities opens up possibilities far beyond just this one dwarf planet. Many of the icy moons and planets in our solar system, such as Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, have been identified as having subsurface oceans. These moons are much smaller than Earth, but the presence of liquid water beneath their frozen crust suggests that life might be able to exist there, even if it isn't the type of life we are familiar with. Because of this realization, astrobiologists have been pushed to reconsider the idea that life requires specific conditions, such as those found on Earth. It may be that life in the universe can exist under very different circumstances than previously thought, perhaps in the subsurface of icy moons or even in the oceans hidden beneath the crusts of dwarf planets like Ceres. One of the most intriguing aspects of Ceres is its complex history, which is hinted at by its unusual surface features. The bright spots, especially in craters thought to contain salt deposits from evaporated water, are strong indicators that the dwarf planet went through periods of geological activity. If liquid water did exist on Ceres in the past, it could have been a vital part of a wider process of chemical and mineralogical transformation. The intricate combination of hydrated minerals and salts found on the surface may suggest that Ceres has gone through a lot of changes over time. Such changes may have been driven by heat generated from internal processes, such as the decay of radioactive elements within its core, or by the influence of space weathering. In addition to potential signs of cryovolcanism, Ceres' surface is also marked by numerous large craters. These craters provide a geological timeline of the impacts it has experienced over time. The impact craters reveal much to scientists regarding Ceres' early life. They have shaped the surface of the planet and are essential for comprehending the period of bombardment that affected the early solar system. Studying these features can provide important details regarding the distribution of mass in Ceres and assist scientists in modeling its internal composition more precisely. In addition, Ceres is of particular interest because of its location within the asteroid belt. Unlike other moons and planets in our solar system, which orbit around larger planets, Ceres lies in the midst of an area teeming with rocky bodies. Its presence in this belt means that it may have once played a key role in the early formation of planetary systems and may have contributed to shaping how other bodies are distributed in the region. Scientists are also using data from Ceres to test models of how planetary bodies form in the presence of gravity and various materials. These models can help shed light on the processes that led to the creation of the planets we know today. The potential for future exploration of Ceres is vast. With new missions, including the potential to land on its surface or drill into its icy crust, there may be even more groundbreaking discoveries in store. These future missions could focus on exploring Ceres' subsurface, examining the properties of its frozen and liquid water, and figuring out in greater detail how its geological processes work. The exclusive combination of features on Ceres makes it an exciting target for further exploration, and its findings may help us understand more about the conditions needed for life elsewhere in the solar system. Additionally, the study of Ceres may provide clues to the broader concept of habitability. While Ceres itself may not support life as we know it, comprehending its structure and geological processes could give us a better understanding of the ingredients and conditions necessary for life on other distant worlds. The possibility that life could arise in environments vastly distinct from our own is an exciting and motivating concept. Many ongoing scientific endeavors, whether in subsurface oceans or in environments with extreme conditions of temperature and pressure, provide critical pieces of the puzzle in our search for life on other planets. As we venture deeper into the cosmos, each mission and each discovery strengthens our understanding that life, or at least the essential ingredients for it, may not be as rare as once believed. The discoveries at Ceres are reminders that even in the most unexpected corners of our solar system, dynamic processes may be at work, quietly shaping environments that could one day reveal profound secrets. The implications extend far beyond Ceres itself. If this small dwarf planet, nestled within the asteroid belt, can retain evidence of geological activity and subsurface water over billions of years, then the prospects for finding similar, or even more advanced, conditions elsewhere grow exponentially. In the coming years, as technology enables deeper exploration and more precise study, we will likely see missions designed not just to orbit or fly by such bodies, but to land, probe, and possibly even return samples to Earth. Each of these missions will add new chapters to our understanding of habitability beyond Earth. Moreover, studying Ceres and bodies like it allows scientists to refine the models of planetary evolution. We can better predict where habitable environments might exist, not only in our solar system but also in the many exoplanetary systems now being discovered by observatories like Kepler and the James Webb Space Telescope. The Dawn mission's legacy, therefore, is not just the rich trove of data it has delivered, but the sense of wonder and possibility it has rekindled. By proving that even small, cold worlds can harbor the ingredients for life and dynamic geology, it challenges the assumptions of the past and opens up entirely new paths of inquiry. In a broader sense, the story of Ceres is the story of exploration itself, a relentless pursuit of knowledge in the face of the unknown. It teaches us that the universe is full of surprises, that life may flourish under conditions we have yet to imagine, and that humanity's greatest journeys are still ahead. As we stand on the edge of these discoveries, the bright spots of Ceres shine not just as mysterious geological features, but as beacons of possibility, guiding future explorers into the vast, uncharted frontier of the cosmos.